Bismillahirrahmanirrahim. Now start with superposition theorem.
Yes, sir.
Superposition theorem. Okay. Let's make a circuit diagram and then we will calculate how to find the value of current, voltage, and resistance in those type of circuits. For example, uh, my my circuit is like that. It have a battery source of somewhat, and then there is a resistance, then there is a node, then also there is a resistance, and this is a complete path, then there is a this must be divided here, that is potential divider, and there's another node, and then there I have another resistance like that. So at the this is basically grounded, and then from here it is a short circuit. So this short circuit has some value of current. So then this is my circuit diagram just like that. Okay, so let's start with this type. So this is my start with my nodes. This is my node A and this is my node B, and this is my positive and negative terminal of battery, and it carry uh, for let's suppose 60 watt. So and this open source or the short circuit carry 5 ampere, and here is the resistance having 5 ohm, and then it is 4 ohm, 12 ohm, and 8 ohm. Okay, so this is basically my full-fledged diagram of my circuit. So this is basically the question. This is my question to solve using superposition theorem and find the, for example, find the value of voltage, resistance, and the current. So how to do it? How to make my, for example, make my diagram for the whole circuit. So for this, first we have to this is for solution, or for example rules. General rules to solve superposition theorem is, first you have to split the sources. Split sources. So how many sources in my given diagram or given question? First source is this one. First source is this one, and second source is this one. So for first source, when I am taking my first source, this one, so my diagram will be, I will exclude this part. Okay, then is it clear or not? And for
Yes.
second, I will exclude this one. First, the superposition rule will be, first I have to split my system. There is basically two types of circuit. First, this is the short circuit, and this is the open circuit carrying some values that of 60 watt or something else, or known as battery sometime. So for the first system, or when I'm taking the system of one, this is my system one or the source one, so I will exclude this source two. Okay, then when I am using the source number two, that is this one, when I use this source, so I will exclude this part. Is it clear then?
Yes, sir.
Okay, now going towards the solution. So how to solve these type of questions? So first solution, step number one will be, step one will be now there are two nodes A and B. You have to also counter these two nodes. So my so my first, when I am taking the first case number 1, when I am taking the source, this battery source. So this will be the little terminals, little terminals, little terminals. Okay, so this is my, when I am
Yes.
taking the source number 1, so it has a 60 watt here, and the resistance value 5 ohm here. This is my node point A, node point B. This is my 4 ohm. This is my 12 ohm, and this is my 8 ohm. Now, first we have solved with the last part. So this is my battery source, and the last part I will solve my numerical like that, from last to the battery source. Okay, is it clear? From the end part to the starting part. So when I am taking this loop number 1, here is basically 12 ohm resistance, this is 4 ohm, and this is 8 ohm. So here there is a divider. So this divider basically means that if these two are in series, so this must be in parallel. So this means that 20 ohm resistance, that is my 20 ohm is parallel to 4 ohm resistance. Is it clear then? Due to potential divider. Any question?
No, sir.
So when there is parallel, so the equivalent resistance will be 1 upon R, 1 upon this 20 plus 1 upon 4, and this will be the value that is reciprocal. So reciprocal means the value having power -1. After this, we have to solve this. We have to solve this. So this will be like that. That is 20. So this must be 1 plus 4, 5s are 20. So 5 multiplied 1 equals to 5. So this will be 6 upon 20 inverse. 6 upon 20 inverse. So the inverse sign means that the value will reciprocate. So this will be, as is 6 upon 20 minus 1, so it must be 20 upon 6. And the answer will be 2 times 3 is 6, and 10 upon 3. So the equivalent resistance between these 2 points are basically 10 upon 3. So 10 upon, this is the value of what? This is value of basically the equivalent resistance for parallel circuit, that is this one. Okay, so the value basically is 10 upon 3. Now, as we know that the V equals to IR. Okay, so have you written down? Then have you written down? I'm going to raise it.
Yes.
Okay.
Sir, I actually know this, but it's okay, no problem. Good for revision.
Okay.
The superposition, you deactivate first the current, like from the right until the left, and then you get like.
Yes. Now I equals to.
Yes, I equals to.
I equals to. Basically V equals to IR. General formula is V equals to IR.
Yes, sir.
And then I equals to,
No, this is KCL.
yes,
KCL.
P upon R. So the value of V is 60, and the value of my resistance, or that is R. So what about R? So R, basically R for this equivalent resistance is 10 upon 3, as I calculated, equals to 10 upon 3. Is it right?
Yes.
Okay. Now there is another resistance, that is 5 ohm. Now this resistance and this resistance is series, is in series. Okay, so this will be 5 plus 10 upon 3. Is it clear? Is it okay or not?
Yeah.
Okay. So this value basically is something 3.33. Okay, approximately. So this is 60 upon 5 plus 3.33. So this will be 60 upon 8.33. So the value of I calculated, it is equals to something about approximately equals to, this is 5 to 40, and this is, for example, it is 7.2. That's good. Okay, ampere. Approximately equals to this one. Now what is the next step? So next step will be to find the value of voltage for my terminals, for my terminal A and B. So how to find this? So for first one, I basically equals to, so just a minute, VA equals to 60 minus for terminal A, for just terminal A, 60 minus what the value of, as V equals to IR. So what the value of I is 7.2, and the value of R is 5 ohm. This point is clear, Zain, or not?
Yes, sir.
Okay. So for A, it will be, I think, from calculator, it is 60, not 6. It is 60. So 60 minus this. So the answer is 24 watt. So V of A equals to 24 V. So any question till now, Zain? Okay. So for I, how to find the I? How to find the value of I? Is there any question or any idea?
I don't remember exactly, sir.
Okay. So for this circuit, this circuit, as the value at, just a minute, I have to raise some parts. This one, also this. Okay. So this is my point A, and the value of voltage at point A is 24. This means that the battery source supplies voltage at 60 watt, and here at point A it decreases to 0.24 watt. So the value here is VA is 24 V. Okay. Also I have to realize each and every point. Now the equivalent resistance, that is for whole circuit, is this one, that is it equals to approximately equal the current approximately equals to, for this circuit, for A, here the current is for battery to till point A is 7.2. 0.2 ampere. Then any question till now?
No.
Okay, okay. Now this is that I move from battery to till point A. Now this I will go here. So how to do it? So for this I will erase it. Erase the points. Okay. So for this I equals to what? I equals to for this part, this one I identified it again. For this part of 4, that is of 4V. So first the current go here, then it go here. So here it is the value will be I equals to at I equals to V upon R, V upon R for this point. So what will be the value of V? Now here at node, the value we calculated that the value is 24 watt. Okay, then that is 24. And what about the value of resistance? That is 4 here. So 24 upon 4. So the value must be 6 ampere. So the current at this point, this resistance equals to 6 ampere. Then any question till now? Okay, okay. Everything is clear. So
Yes.
this is the value of I calculated. So after this, I have to go to my terminal B. This is my B. So VB must be as I VB must be equals to VB equals to VA, that is this point. Now this point as VA equals to 24. Now from this point it will go here, but there is a resistance, that is resistance of 12 ohm. So this will be equals to V equals to IR. So I will subtract my this coefficient of resistance. So VB must be VA. VA is 24. 24. Then negative sign. Then what is the value of ampere? That or what the value of basically value of I? Value of I is 1.2 for this system, and for R it is 12. So this will be that here the value is 1.2 we calculated before, and VB will be equals to 24 minus that will be 9.6. So VB equals to 9.6. So this value at V voltage equals to 9.6. Now moving further. Now we will cover the here. So I will move here. So this will be as I discussed that is equals to I equals to V upon R. So what the value of V is? V value basically is 9.6. 9.6. 9.6 upon the value of resistance is 8. 9.6 divided by 8. So this value will be something VB, that is 96. Okay. So this is 9.6. This is approximately equals to 1.2 ampere. So here it is 1.2 amperes. Now from this system we will derive many parameters. So I will then everything is clear.
Yes, sir.
Okay. So just give me 1 second. My conclusion is .
嗯
my conclusion is that V at A is 24, V at B is 9.6, and my value of the current at this circuit, because here it is completed and it is also used here. So this is, for example, I use this as my current source 2. Okay, this is my resistance 1, or let's suppose resistance 2. So I2 is 6 ohm. Now moving towards my step number 2. So this is the step number 1. For step number 2, I will use this open circuit or short circuit, and I will basically split this part, and then I will not use my battery source. So for my second step, okay, this is my step number 2. So step number 2 will be, there is my short circuit of 5 ampere. Here is my node. Here is my resistance. Here it is also a resistance. This is another my node number 8. Here is also a resistance, and there it comes a resistance of 5 ohm and a open link or open wire link. So for this is my circuit number B, and this is my A. So these are my two basically nodal points where basically voltage drop, or sometimes known as dropping voltage. So this will basically drop my voltage and my current across all the terminals. Now for this is my 5 ohm, sorry 8 ohm, this is my 8 ohm, this is my 12 ohm, this is my 4 ohm, and this is also my 5 ohm. Okay, so these are basically, now how to start it. Is there any idea how to, where I start? I will start just like before that. I will dissolve with my resistance values. So first I will compare that these two are parallel, that 5 and 4 are parallel. Okay, so this will make that 5 is parallel to 4. First is this one, 5 is parallel to 4, and when this is solved, so this must be in series with 12. This must be series, that it is plus with 12, and this whole is parallel with 8. Is it clear, Zen? Or yes. I will do two separately. Is it clear?
Yes, that's clear.
Okay. So what basically 5 parallel, this means that this will be 1/5. This is the equivalent resistance, that is equivalent resistance for whole circuit. So at this, basically I am solving 5 parallel to 4. So 5 parallel to 4 means 5 is 1/5 plus 1/4, and the value is inverse, and then this value will be plus with 12, and at last, at the end, I will do my next step. So for this, the value will be 5 times 5 multiplied by 4. This must be 20, and this will be uh, 20 and then 4 plus 5, 4 plus 5, and then there is an inverse sign, plus 12. After this will be 9 upon 20 inverse, 9 upon 20 inverse plus 12, and inverse will be 20 upon 9 plus 12. 20 upon 9 plus 12, as 20 upon 9 is approximately equals to 2.22, so this must be 2.22 plus 12, so this value equals to 14.22. Now this is 14 point, now this 14.22 is parallel to 18, so we have also do this, that this 14, oh just a minute, this 14 plus 22 is parallel to 18, so this will be 1 upon 14.22 plus 1 upon 18. So how to do it, how to do it? Now taking the first, you must take the LCM. So the LCM of 14, just a minute, 14.22 and 18 is 25.255.996. So just a minute, I have to raise it. So this will be 255.96, and there must be the sum will be, here it is 18 time, and this must be 14.22 times. Now add 18 plus 14.18 plus 14.22. So the answer here is 32.22, and then divide this 32.2 with 255.96. So what will be the answer? 255 divided by 322 divided by this one. No, this is basically, just a minute. This is basically, as this is parallel, so parallel will be power of -1. These all are in -1. First you have to reciprocate it. So this must be 255.96 divided by 32.22. So now you have to find it. So the answer is 255.96, then divided with 32.22. So the answer is 7.94. So equivalent resistance is 7.94. Then any question? Everything is clear, Zen?
Yes, sir.
Okay. So the equivalent resistance is 7.94. So I have to raise some part. Okay. Have to raise some parts. Just a minute. 7.22. Okay. Okay. Now After this, for a little consideration, I will suggest you some, just a minute. Now, now for a little diagram, that is for my system that having 8 ohm and 14.2. So 14.22 means that this is basically my parallel circuit and having some source. So this source will be just like that. I having the, I will use this circuit. So there is my, here it splits. Now splitting basically is, this is my 8 ohm and the equivalent resistance that is parallel. So the answer basically of it is approximately equals to 14.22. This is 14.22 and there is a, this one. So there is a source energy or source ampere. So this value equals to the ratio of 14, just a minute, SA will be the current in this portion, okay, in this portion, because I am dealing this portion. Just I am, I will, this is in horizontal vertical, and now I convert this into the vertical plane. So this SA equals to the this one, the largest one, that is 14.22, then divided by with the value that is I think 22.2, and this value is approximately equals to the source voltage. What does, now here it is multiply, sorry, source voltage equals to voltage, source ampere, sorry, that is 5 ampere, multiply with this, divided by this. So the answer approximately equals to 3.2 ampere. This is basically the value of current in this, that is 3.2 ampere. Now this is for this circuit, that is 3.2. Now there must be some current loss. So what will be the current loss? Here there is 3.2, so the total is 5 ampere. So the for it is 5 minus 3.2, so this will be equals to 1.8 ampere. So where it comes, so there is basically a ground source. So here it is basically 3.2, and from here it is dropped by 5 minus 3.2, that is 1.8. Just I mean, I have to change the color. So this will be 1.8 ohm, sorry, 8 ampere. Okay, is it clear, Zen? Zen, any question? Zen,
Yes, sir.
any question till now?
No, sir.
Okay. Now I am going to erase the part. So I will erase this, and now I am considering this as a block. Okay, for this, what will be the value of current? So this will be according to voltage divider. So using the voltage divider theorems, now there is basically 2 ohm, that is 2 amperes. First is the 5 ampere resistance and second is 4 ampere resistance. So both are basically are parallel to each other, this and this. So this will be like that, 4 ampere and the 5 ampere. The current that is entering in my system is 1.8 ampere. 1.8 ampere. Here it is 4 ampere. Here it is 5. And what will be here? What will be the value of current here after passing through this circuit? So this will be equals to 1 upon 1.8. Then the value of this one, that is 5, that's larger one. Then divided by 5, and the second is 5 plus 4. So this will be 1.8 into 5. So this is 8. 1.8, 5 upon 9. So this value is approximately equals to 1.8, and then this must be equals to 1 ampere. 1 ampere. So the current passing through this circuit, that is this one. The current in this resistance is 1 ampere. That is 1 ampere. Now for this circuit, how to find the value for this circuit, that is for this one, for 5. So this will be the total source. Total source is 1.8 ampere. That is given into my system. Here the value is 1 ampere. So this is 1.8 minus 1 ampere. So this will be the current in my 5 resistance. So this will be 0.8 ampere. So the value of current for this is 0.8 ampere. So I use voltage divider theorem here to find the value of voltages, to find the value of current in my respective circuits. So this value will be 1 ampere for 4 ohm resistance, and for second one it will be equals to 0.8. So how now what will be the voltage value at B? Now this will be find. So what will be the value of voltage at B, and what will be the value of voltage at A? So how to find it? So for VB, just a minute, I have to raise it. Yes. Okay. Now for VB, because the current first pass through point B. So this will be for part B. VB equals to what will be the value of current in this circuit, that is 3.2, and this will value resistance is 8. But as we know that here there is no resistance, it will cover this path. So this path is clockwise. So clockwise is always negative. So there's a negative sign in here. Is it clear? This point is clear, Zen, or not? Zen, is this clear? So this is basically VB equals to minus 25.6 watt. Now for as V equals to IR in my case, and there is a 0 watt here, so there must be no drop here. So this will be V equals to IR, and there must be drop of 0 minus the value of voltage at A. So value of voltage A equals to VA and is equals to IR. Again, the current passes from this is the clockwise. So clockwise is always positive, always negative, sorry. So 0 minus VA equals to negative times due to clockwise. Value of I is 1 ampere. Value of resistance is 4. So this will be 0 minus VA equals to minus 4. So the value minus VA equals to minus 4. So this will make that my value of voltage at A equals to 4. So this is the complete solution of my superposition theorem. Zen, is there any question? Hello, Zen. Zen? 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 Hello? Hello? Zen, is there any question till now? Zen, are you with me?
No, no,
Okay, okay, okay,
no.
okay.
Yes, I am with you.
Okay, okay, okay. So this is basically the complete method to how to solve the superposition theorem. So there is basically multiple examples in your exercise. Now we will do my exercise number. Just a minute. We will do the example 4.2. So example 4.2. Then okay, I will cover each and every example. Okay. So you will be, inshallah, there will be no problem regarding any examples. So for example 4.2, this is example 4.2. So example 4.2, we have to find the value of V1. We have to find the value of V1 in the circuit. The circuit is like, this is a complex circuit. So this will be like that. There is a first battery source. There's then a resistance that is known as R1, having some resistance. Here it is the point that is V1. After this, there is a straight line having no resistance. No, no, there's a resistance also. Just a minute. I have a resistance here. Then there is also resistance for this loop. Then there's a current source here. Then there is a first diagram. Then there's a node number 2. Then there's also a resistance. This is my, in this case, this is my resistance number 4. And here it is the drop to my system. And then there is a resistance also. And there is my another battery source. Now here there are basically 3 sources. Two are battery sources and one is my current source. So how to tackle these types of systems? So for this one, this is my positive, negative, and now I will put some colors to show it. That is my VS1, voltage source 1. This voltage source 1 having 10 watt. Now the first one is the resistance number 1, R1. So R1 is 22.5. R1 is 22.5 kilo ohm. Here it is the point number 1. So point number 1 have the V1. Here it is the point 2. So point 2 must have the V2. After this, Yes, this is my R2. R2 is 40 kilo ohm. R2 is 40 kilo ohm, and this is my R3. R3 is also 40 kilo ohm. 40 kilo ohm. This is my current source of 1 milliampere IOFS of 1 milliampere. This is my R4. R4 is 48 kilo ohm. This is my R4, 48 kilo ohm. This is my R5, which is 12 kilo ohm. 12 kilo ohm. This is basically my voltage source VS2. This voltage source is 20 watt. Now I have to find the value of V1. So how to find the value of V1 from this circuit? So as according to my superposition theorem, first I will split my variables. So my first diagram, this is my first source. Just a minute. This is my first source number 1. Okay, this is my second source, and this is my third source. Okay, so I will split my diagram in 3. So my diagram, there will be 3 diagrams for my system. So for first case number 1, case 1, case 1 using VS1. So VS1, there will be no VS2 and IS. So there must be like that. There must be a voltage source. There must be here. There is V1. There must be some value of this here. Then it comes that there is no voltage source. Okay, so there is only V2 here. Then there is a R4. After this there is R5 only, R5, and there is only one. So there, when it is VS1, so there will be no VS2 and IS. So the value for this is 10 watt, 10 watt, 22.5, and respectively from diagram. When I am using the VS2, so there will be no VS1 and no IS. When I am using IS, so there will be no VS1 and no VS2. So for this basically diagram, for this one, case number 1, so first to use it, first I am using that RA equals to, now I am using some parameters. So first I am using that RA. Now this is for case number 1. RA equals to, as I described, that RA equals to R4 parallel to R5. Okay, then is it clear? I replace that R4, RA is parallel, RA is equals to R4 parallel to R5. So this will be written as 48 multiplied by 12 divided by 48 plus 12. This must be equals to value that is 9.6 kilo ohm. Now I will resolve this R4 and R5. Now for RB, RB basically is R3, R3 this one, this is the 3, R3 plus RA. So this will be RB equals to R3 plus RA. What the value of R3? R3 value is 40 and the value of RA is 9.6. So this is approximately equals to 49.6 kilo ohm. Now for the last part, RC. Now RC is when I am using this my 1 and this is my 2. So RC basically is when R2 is parallel to RB. So this will be RC equals to R2 is parallel to RB, and this will make that it is equals to 40 multiplied by 49.6, that is my RB value, 49.6, then whole divided by 40 plus 49.6. This is the value of RC. So RC after the calculation is approximately equals to the value that is 22.15, approximately equals to 22.15 ohm. Now using voltage divider, according to voltage divider rule, voltage divider rule, according to voltage divider, how to solve it? So as we know that according to voltage divider V11, as we have to find the voltage drop at 1, this is my voltage source 1, this is my V1. So this first be V11 equals to Vs1, that the source voltage 1, plus, sorry, multiply with RC, RC is this one, divided by, now this is the parallel with R1 plus RC. So R1 plus RC. What is the value of Vs1? Vs1 value is 10 multiplied by the value of RC is 22.15. It is 22.15 whole divided by 22.15 plus the value is 22.5. So 22.5. So what will be the value? The value is approximately equals to 4.96. 4.96. This is the value of V11 for case number 1. Now for case number 2. So for case number 2, there will be no VS1. There will be no VS1 or there will be no IS. So for this circuit, so there will be no VS. So there will be a VS1, sorry, VS2. VS2. There will be this is case 2. For case 2. For case 2, oh, just a minute. For case 2, there will be no, yes, this will be open. So for case number 2, we also find all the values of resistance, then also find the value of V1 for my system. So this will be, okay. Now for this case, that is my case number 2, this case 2, case 2. Now for case 2, what we have done, we have to do that my R1, this R1, this is the R1, that is 22.5, this is the R1. R1 is parallel to R2, yes. So I will take as RD. So RD means that R1 is parallel to R2. So the value must be, it is equals to 22.5 multiply by 40 whole divided, this is 22.5 and this is 40, whole divided by the value 22.5 plus 40. So this will make the value equals to 14.4. So RD equals to 14.4 kilo ohm. Now this value is basically RD, and now for this is basically will be, this is the RD when it is, so this will be in series, so this will be R3 plus RD, so I will take as RE, so RE will be R3 plus RD. What is the value of R3? R3 value is 40 and RD value is 14.4. So this will be equals to 55.4. 54.4, sorry, 54.4 kilo ohm. Now for the next one, it is basically R4 and it will be parallel to RE. So I will suppose that it is RF. So RF equals to R4 is parallel to my value RE. So this value is 48 multiplied by 54.4. 54.4 whole divided by 48 plus 54.4. So this RF value is approximately equal to 25.5. 25.5. So now according to voltage divider method, so I have to find that V11, that is V1, for this case it must be V11 equals to V13 multiplied by RT upon R3 plus RD. So this will be equals to 13.6, here is the value 13.6 multiplied by the value of RD is 14.4, it is 14.4 whole divided by what is the value of RC? RC value is 40 plus 14.4. So the value will be equals to 3.6 V. So after this there is case number 1, case number 2. Now for case number 3, when I am using only the current source, the value of V is approximately equals to V equals to, for third case 3 equals to 3 equals to 2.16. So for the total value of V, so how to find the total value of V? So total value will be the value of V1 from case number 1, case number 2 and case number 3. So the value of now V1 equals to value V11 plus V12 plus V13. So V1 must be equals to, what the value of V1 is, V1 we calculate is 4.96 plus V12 is 3.6 and V3 we calculated is 2.6. So after the summation, this value is V1 equals to 10.7 10.72. So this is the way to calculate the values of voltage while using superposition theorem. Then Zen, any question? Zen, hello. Then are you listening me? Then is there any question? Hello. Zen, hello. Hello, Zen. Hello, Zen. Hello, hello. Zen, are you with me? Zen, hello. Hello, Zen. Zen, hello. Zen, hello. Zen. Hello, Zen. Zen, are you with me? Hello, Zen. Hello. Zen, are you with me? Zen, are you with me? Hello, Zen. Hello, Zen. Hello, Zen. Hello, Zen, are you with me? So this might be the end of today's lecture. So I think you are not here. So I think this will be the end of 1 hour. So goodbye from this lecture and Assalamu alaikum.